a lot of these heritage walks, Mike?
No, this is my first one.
Oh, okay.
One and only. Who came to my talk? Just raise your hands if you came to my talk last night. Okay. For those of you who don't know, this is a machine for processing limestone. And you can see limestone right there untouched in that rock outcropping. The lime is broken into bits, usually with the use of dynamite or some kind of device, whether they bore holes and crack it open. It is then reduced to headstones, head-sized chunks, and it is loaded into the very top of that kiln. And that kiln, from those bars all the way up, would be filled to the brim with these limestone headstones. They would then be burned, quote unquote, basically fired by fires that were started here and on the other side of this. And those fires would push in the heat into all those headstones where it would then flow through it. The temperatures that were created in order to burn this limestone were between 1500 and 1800 degrees Fahrenheit, which is sufficiently hot enough to melt aluminum, to give you an idea, a molten aluminum, molten copper. What would then happen is, as this limestone degraded and became chalkier and dustier, down below this there is what's called a draw tunnel. So there's an opening down underneath this, which a man, the lime burner or the fireman, they had two names for the man, he would go down there, and there is a horizontal door that he would pull open, and the limestone would either fall down or he would rod it down. In this depiction of this, there are guys who used rods to make it fall. This stuff now, anywhere from 1500 to 1800 degrees, would fall down into a kind of two-wheeled barrow, which would then be taken out onto a cement floor, poured on the floor, dispersed in order to cool it. Every one of us has put out a campfire. You know what you do to kill a campfire in the heat? You spread it out. So the lime would be spread out.
So
and
it's in powder form.
What's that? Powder, and maybe some rock was left. So it would be spread out to cool, and then men would go into that and they would rake for the consistency. Some lime would be overburned, discolored, or underburned. And so they'd try as best they could to decipher from the color and the product what they would edit out and what would be what is then called quick lime. I went into it last night. It's kind of boring, at least for me as a non-chemist. Calcium hydroxide has carbon dioxide removed during the process. In this case, what is on the floor is what's known as calcium oxide. Quicklime, the thing that we most commonly refer to, but in one of its forms, as lime. The problem with this lime is that it is highly reactive to water. There was a roof that extended from this pier, and you'll be able to see it, you can look for it now that you're beginning to think about it. There's another pier down there that's been toppled, and correspondingly, if you look over to the left, there's another pier still standing. The roof from here went down, went over that pier, and went another 40 feet. And if you look down here, you can see the end of the foundation of this entire structure. So this structure would have had a roof on it, and it is 50 feet wide by 80 feet long. And the purpose of that was to keep water off the calcium oxide, the lime. If the water got into the lime, it is an exothermic process that has begun, which means it gives off substantial amounts of heat. How much heat? If it's not closely monitored and you put water on calcium oxide, it can reheat to 200 to 500 degrees and expand by 2.5 times. So it can actually, if you put water on it, you could potentially, if you put it on a piece of wood and you started it and you put a lot of water on it, it could start burning the wood. And so there are numerous reports of this material. I can't say numerous, but I've had a couple of reports. A farmer over at the lime kilns further up in Sheffield got a wagon load of this calcium oxide quicklime, and on his way home his wagon caught fire. There's another report of calcium oxide being stored at one of the lime kiln buildings down in Canaan, and it rained heavily. I don't know whether the roof failed or whether the terrain and the failure was in the foundation of the building, but the rain came in, got into the calcium oxide, and blew the roof off of the building. So at that point, this stuff is dangerous to deal with. The next step with this quicklime is to slake it. Have you ever slaked your thirst? That's what is happening. And there are 3 forms of slaking. One is dry, where you add very, very measured fashion a certain amount of water slowly, and you mix it all up, and it still stays as powder. The lime still stays as powder. Then there's wet slaking, which now the powder, you've added just enough water so that the consistency of the stuff is more like putty, and that becomes the stuff that is very valuable in terms of, if you look at all the painting that was done in the 1800s, you're looking at lime-based paint. And because of some of the mineral content in this, some of this stuff can be effervescent, it changes color. So painters who want to really have super duper painted walls, interior decorators now, lime paint, oh yeah, or lime plaster, and you add color, and they try to imitate those old plaster walls that you would see in the 1800s. So it was paint, it was plaster. The slaked lime would also be used in mortar. So a lot of these old buildings, pre-1900, especially the Victorians, if you look at those old stone walls, that is the slaked lime in putty form that has been turned into mortar with additional material. So, and then there's a final form of slaking. Well, I can't really call it slaking. It's called hot lime, where you take the quicklime and all at once you add all the other ingredients to make cement or concrete. A little more dangerous, a little, but the Romans loved it. Their use of concrete is now labeled as the concrete revolution, because all of their aqueducts, all of their major buildings have some form of this in them. So if you look, there were, just to give a quick example, there were, during 312 BC from about 26 to about 260 AD, there were several hundred Roman aqueduct systems built, 11 into Rome itself, and then you can find them in Spain, France, Constantinople, Istanbul, down in North Africa, coming out of Carthage. The one down in Carthage, that system, the aqueducts that we see as these great arched structures, are less than 20% of the entire aqueduct system. Most of the system consists of pipes that carried the water with a roof over them in order to prevent debris and other material falling into them. But these things are monstrous, and the longest aqueduct system, as if I remember correctly now from my reading, is over 80 miles long. So what a testimony to the use of concrete and Roman engineering that is. So here we have America. It starts out, lime kilns showed up here right away. They showed up with William Penn obviously down in Philadelphia. There's also a lime kiln, which may have come earlier than that, on Rhode Island, which I believe got folded into a house owned by Benedict Arnold. Okay, so in terms of constructing buildings out of brick, lime mortar, when you look at Philadelphia and you look at all the old buildings and all those brick structures, lime mortar, lime mortar. How much was it needed? It was hugely demanded. But not only was the demand for construction, the lime, even quicklime, both quicklime and limestone, which was then crushed, are used by farmers to change the soil acidity to make it crop worthy. So big demand by farmers to turn unarable land into productive food producing land. Big call by construction of all your major cities. So, and you've got in the late 1800s, late 1800s into the 20th century, you've got immigrants coming in by the million. So the demand for housing, has anything changed? The demand for housing was extreme, therefore the demand for product that would come out of something like this. This is what's known as, now, very quickly, the earliest lime was prepared by digging a pit. You threw in some firewood, you threw in a layer of lime, you threw in some more firewood, you threw in some more lime, and you burned that for 3 days. You gave it another day and a half to cool down, and then you brought it out. Those pits only produced, for all that burning, effectively were only 20% productive. So as lime was like, we've got to have more lime for our building. So this is what's known. And so they started, you can see it in England in particular, they started building stone structures and started elevating it. And so those stone structures for that next revolution of lime burning evolved into this. This is what's known as a vertical shaft lime kiln. And there are all kinds of variants of it. The variants that were established up in Sheffield at what became the Berkshire Hills Company, originally owned by the Barnes brothers, are fire brick on the interior to resist that 1500 to 1800 degree heat, surrounded by normal brick. And they are this high, but because the brick is prone to deterioration, and these things are burning, and there's such a differential of the heat inside and the heat outside, all those kilns are covered with steel skins, all of which have been removed for recycling up at the Barnes kilns. And this is where this particular kiln starts to depart from that particular iteration of kiln construction. This is poured concrete. There are some revolutions that were going on with the turn of the century into the 20th century. One of them was concrete and structures. And what this represents, as far as my research goes at this point, which is very shallow, this is the first evidence that I have of a concrete silo. Now, concrete silos would, in the 20th century, go on to become very popular with farmers, especially when you hear about all the bad weather in the Midwest, and silos, grain silos. They were made out of wood initially, then you make them out of steel and so on and different stuff. But concrete, hoo-yah, that's surviving tornadoes and all that nasty weather that can come through. This particular example is how they were built and probably predates those farmer silos. So what happens here, when you look up here, you see those individual horizontal bands? The carpenters were brought in and they cut short pieces of wood all the way around that circumference. They banded them probably with a hoop of steel, and then they banded them in an internal band, and then they poured the concrete into that. And what makes this even more outstanding is they put reinforcing steel in it. So this is probably one of the first reinforced concrete silo structures in America. And so what happens, each time they pour a ring, they let the concrete cure, and then by some means, they loosen up that big ring, both internally and externally, and they raise it up, set it, pour the next concrete. Whew, a lot of work.
And how did they get it up there?
Well, see, these are the questions that just, see, this kiln was built in 1909. Cars are not on the road in any degree, so there are no trucks. The railroad is literally 1.5 miles away, and there's no railroad to here. So everything that was done here was brought in by horse and wagon. So bringing in cement to mix, bringing in all the wood to make this, cutting it, assembling it, bringing in the steel. I look at the amount of work and I'm going, I'm tired already. And so this is actually a phenomenal piece of, for somebody like me, this is a great demonstration of not only industrial, archaeology, but also art, and especially craft. The whole business of doing this just blows my mind. Now, there's a roof that extends over that. It's a sloped roof, shed roof, that extends all the way out to the end. But the question becomes, the next question is, how the heck do you get lime up there? And you'll see in Canaan, the historical pictures there, they had one operation where they had a cable up to a great big tower, and this cable there would be 5-gallon buckets, little 5-gallon buckets, carrying the stone up multiple stories and finally dumping it off up there. But that's not the way it was done here. Behind us, we have concrete pillars. And what I've done, in order to help visualize this, these concrete pillars are part of a bridge system that goes all the way up this hill. Poured concrete here, you can see the next pair of poured concrete pillars, and there might be an intermediate pair that I haven't found, but then the next one, you'll see there's an orange cone that I've placed, and that's in alignment with this side of the pillar system. That goes up, and then there are actually 3 cones up there. That goes up and up 35 feet, and then once at the end of that 3rd cone, it then goes another 14 feet, and it now is no longer pillar system as much as it is concrete horizontal beams that stretch 30 feet. So there was a railroad up here off of a trestle bridge, bolted into these reinforcing anchors. And I think of that. I'm going, and then I'm going over here as a woodworker, lifelong woodworker, I'm going, whoa! So the whole system of building, I've never built a bridge, and I look at this, but I love bridges. I mean, there's something about them that's just so fascinating. And I look at the engineering and then the actual construction, because this would have been a combination of wood that was bolted together with big honking, you can see a couple of them bent here, big honking fasteners to keep it all together, on top of which was probably a boardwalk in which the center was some kind of railroad car. These piers, for the most part, the width of that kiln is basically 14 feet. These pier sections from here on up are 14 feet. So it's my estimation, my hypothesis is that the cart was centrally located with a walkway. Now, you couldn't back this thing up or use animals to bring this cart over because most of them would spook. Forget mules. They'd kick your teeth out before they got allowed themselves to be anywhere near this system. So these carts were probably pushed by hand. And then they were brought over, and I have to assume that they had some kind of a dumping mechanism to forward dump into the stack up there. So this whole thing, can you imagine this is a trestle bridge? Next time you see a large, like, Western-style bridge with some locomotive going across it in some movie, and you're going, wow, that looks dangerous? I'll bet you this looked equally dangerous. So, and of course, with all things, as with the Roman aqueduct systems, all the wood is gone. And the aqueduct systems in Rome required a phenomenal amount of wood to build the forms that would hold up the arches until the masons completed building the arches. And when you look at one of those aqueduct systems and you start counting arches, you go. So now for the secret ingredient of this one. Not only is this unique and very early in terms of its architecture and the material used, but what becomes even more compelling, at least to me, is who started the darn thing. Okay, so the records show that an Alfred Minor, M-I-N-O-R, and his brother William, along with another miner by the name of Edward, bought the property and created the kiln. Now, who amongst you has read the complete works of Simon Winchester? Anybody?
The complete works.
The complete works. Well, as it turns out, when the research was done, these miners, in particular William, one of Simon Winchester's books, if you've heard him speak, I love to hear him speak. I love the language. I mean, I fall in love with English when I hear him speak. I wish I was erudite. I wish I was well-studied, and I wish I had a good memory. But anyway, he wrote a book about the Oxford English Dictionary and its creation, entitled The Professor and the Madman. Okay? The Oxford English Dictionary took 6-7 decades to create. The madman in this book, the professor was obviously, I think his name was Wallace, was the mastermind and dedicated to doing it. And he relied on submissions from other people of various words. And that includes the complete history of the etymology of the word. Spectacular research. Other than the professor, there was one donor who donated over 40,000 words to the Oxford English Dictionary. And he was the madman. He was a murderer, confined to the Broadmoor Institute Asylum for the Criminally Insane. His name, this is short-term memory, folks, was William Minor. He is confined in England to Broadmoor. He has 2 rooms, and what he does for his 35 years of incarceration in this institution is he spends all his time in his library room in Broadmoor investigating words that are showing up in old books. He is also a Yale graduate, trained as a surgeon, and that's part of what got him into trouble. His half-brother, back in New Haven, Alfred, was a crockery merchant, also trained as a surgeon. Both of these men served in the Civil War. Okay? They're both Yale graduates. Alfred has a son, Edward. Edward goes to Yale and graduates with a certificate in civil engineering. Now, I have a couple of brothers who went to Yale. And I can tell you their preoccupation with education and learning and continuing learning and discussion is mind-boggling in terms of their ability to go out and do physical work and enjoy it and just do it repeatedly, and not so much. So we have this civil engineer. What are they doing down in New Haven deciding in 1908 to build a lime kiln in Sheffield? One is retired as a crockery merchant, for crying out loud. The other is a civil engineer just beginning his career working at a waterworks. Whew. But the author of the design of this structure is clearly the son, Edward. And all things Yale, being Yale, Yale as an educational institution like to be on the leading wave of information. So here he is working in what would be the skinny branch of the tree with this material, new material, and engineering its use. Whew. Now, this lime kiln lasts 4 years. They order in, of course, they hire, one little thing I was going, having been a carpenter for 25 years, I go, who were these guys who were brought in to do this? Nowadays you see carpenters and what do they show up with? Oh my God, they show up with man lifts and all kinds of equipment attached to the back of their truck, and you're going, and I'm counting the numbers and I'm going, $5,000, $10,000, $15,000, $20,000 of their own infrastructure. These guys are showing up with a couple of hand saws, a couple of hammers, and maybe some auger bits. And they're building this. And I go, whew. So there was one gentleman who I was trying to pursue named Clarence Goodsill, lived over in Clayton. How was he getting here every day? He was, in the newspaper, he was the man who was hired to put up a 50 by 80 shed. There is no metal staging. You don't go over to some rental company in the center of Great Barrington and say, okay, deliver, a whole batch of metal staging. You had to make your staging out of wood. In order to put this wood up that high, from there over to the first pier and over to the last pier, you were building trusses and you were putting up there. And then on top of that, you were putting purlins, which on top of that, you were putting a metal roof. How many people were working with him? Just one guy being mentioned here. As it turns out, Clarence Goodsill was 28, I believe, at the time of the construction of this building. He only shows up in one other notice, and that is in 1917 he tries to enlist in the Army, and his skill sets are listed as minimal. And he is 5'6" and 165 pounds. That's a lot of energy. And I have no idea of the number of men that he had to bring here and the amount of ancillary wood just to erect the scaffolding to put the shed up. And we haven't even mentioned the amount of wood that was used to create all these concrete structures. So this is, this thing in the woods that you walk by actually contains an amazing amount of what was then, shall we say, state of the art. Okay, let me roll it back a little bit. Another Simon Winchester book. Interesting how he keeps coming back. He's written a book called The Map That Changed the World. And it is about in 1800, this Englishman, after, decades of exploration below ground in England, created the first geological map of a territory. It's not a surface map, it's not a topographical map, it's not a Mercator projection. It is a map of England showing the different stratifications of the rock under the ground. And he creates this first map, 1800. So here in America, we have, everybody's coming to America, they want to go, okay, lime, how do I find it, how do I get it? As it turns out, there are a couple of men, one man wrote in the late 1800s a book called, basically where stone was and what kind of stone there was in America. He would later visit the Goodale Quarry and rave about their stone. But what was then developed between 1897 and 1917, 1923 was a geologic map of this area. And as it turns out, what we live in is known as the Lime Belt of Western Massachusetts. And it is, as far as I'm concerned, if we'd shown up in America and we knew what we know now about the presence of lime, nobody would be living here. This entire area from one end of the Berkshires down to the other would be just blasted open, and it would be one big strip mine as people were mining limestone. So the lime deposits are everywhere through this area, and they are the geologists that came through on behalf of the U.S. Geological, whatever department they call themselves, who came through in the late teens, mapped these deposits and mapped also the different kinds of limestone that were present in order to judge what kind of purity they had, what other additional minerals had been deposited when the limestone was formed, so that the geology of the area is limestone. Now I have to go to another, keep that in mind. I have to open up the book of limestone, and this is where I just get swamped. Calcium carbonate, limestone, is not just one thing. There is calcitic limestone, which has calcite in it. There's aragonite in it. And then there is dolomite, which is magnesium. So when you hear about the Dolomite Mountains in Italy, high magnesium content. The man who was raving about the Goodale Quarry was talking about the pureness of this marble that he was seeing. Yes, limestone, when compressed, subject to geological torment, compresses into marble. It also, as the limestone is forming, depending on where it is, whether it's close to the sea or it's inland and it's being fed by streams, minerals can be deposited in it. So travertine marble, that's just different forms of mineral that are being deposited on this pie crust of a material before it is finally different limes, when burned, produce different types of product that is then prized by the aficionados. All these wine tasters who have this, they can. Basically, that's what happened in lime. So everybody wanted Goodale lime for carving and for statuary and so on. Everybody wanted lime out of Canaan. And why? Apparently, with that high dolomitic content, high magnesium content, when burned, it produces a superior performing lime. So the question becomes, well, what happened here? The geologists who came through in 1917, and the results of his research were finally published in 23, came to this lime kiln because it was now dead. It had been abandoned 7 years previously, and tried to find out why, part of the reason why this might have been abandoned. And he found reasons for rejection because of crystal, the crystal material inside it. Limestone does have pores, and those pores can be invaded by other materials. And depending on where it occurs, those materials can degrade the limestone. This place is one kiln. It was started in 1909. The kilns up here in Sheffield, those 5 kilns are putting out 100 barrels, 50-gallon drum barrels of lime per week. This poor place may be putting out 25, 30. Up at the Barnes kilns, those kilns up there, they have a train track that's coming right by the building. Oh, you take the barrels of lime, the railroad cars at the same height as the deck, you shuffle them onto the cart, and the train goes down to the railroad tracks that are right next to Route 7. This stuff gets made, it gets put in barrels, and on the far end of that, you're going to see, well, you might not see it, but there is a depression where it is obvious that a horse-drawn wagon was backed in. The barrels are put on that, and then it's carried by horse down to the railroad tracks 1.5 miles away. One of the things about the kilns up here in Sheffield was there were 2 reasons why they put in that railroad track. One is that the Sheffield town fathers of the time refused to allow them to cart the material on the roadway. Second, and this all has everything to do with Teamsters, the costs of cartage were too high. So you begin to see the economic pressures that are showing up on this kiln. Couple that with the 3 owners who are hundreds of miles away, and who, Edward, the son, the civil engineer, even though he's president of this company, is about to get married, he's about to start his new job. His mind is not necessarily focused on this. The father is busy with the crazy man back over in England, and in 2010 he spends the first 3 months in England trying to negotiate the release of the madman to an insane asylum back here in the United States. And it is only with the approval and the review and approval of Winston Churchill that is finally allowed. Wow. So you can kind of see, the master's eye fattens the flock. So a whole variety of economic conditions prevailed here. The costs were rising, production and the purity of the lime was questionable. So it's like striking a hot seam if you're going after coal, or striking a hot seam if you're going after gold. If you run into a cold one, where do you go? It's like, wow. So there you have it. I don't want to draw this out.
How long did it take to build this whole thing if it was only open 4 years?
I've been trying to figure that out. And modern day concrete, you pour it, and the next day you can actually, if you're pouring a floor, you can walk on it. This concrete, I don't know whether it's the more of the modern day variant or the slower lime based, it could have taken several days, which means that each one of these slip molded sections could have been made, the concrete could have been made, and it could have been as little as 2 days, as many as 10 days before they could go to the next one. Because there have been instances where they've not allowed the concrete to age, and the slip forming has failed. So I look at this and I go, just that building alone. And I'm going, no staging, no cranes, and I'm going, it's gotta be 2 months, or maybe a month with 5 guys. And this trestle, it's like, it's like the eighth wonder of Sheffield as far as I'm concerned. So.
You say there's brick inside?
Actually, I've tried to look up, I didn't bring a ladder. The only thing that I can see is concrete lining. I don't see any fire brick. So I think they were trying to be very sexy with their thinking about how to build this thing and get it done faster with less initial expense until they went to concrete. And the concrete wasn't being driven up in a concrete mixer with a guy in the front of the cab sitting in his cab going, "Where do you want to shoot?" Now there's a bunch of guys going, and hand mixing all this stuff. Yowza! So now I've probably gone beyond half an hour with this, but for those of you who are interested and choose to do so, this path circles up around and goes all the way around up to the very top, cuts back in, and you can see the loading area back up there on the other side of the cones, and then it starts to go downhill again. And as you're going down that hill, you can see the quarry, barely. So those of you who might want to walk that, you're welcome to. And for the rest of you who've had enough of me yakking at you,